Okay. Hello again, guys. I'm back and ready for e-learning day 2. I didn't hear from very many of you today, so just make sure you're letting me know if you have questions. I'd be happy to answer any emails, or if you want to contact me on Remind, that's great too. And then also, if you guys want it, we can also do some video conferencing. So if that's something you need, just let me know and we can get that worked out. Hope everyone is staying busy and enjoying your time at home, I guess. And also let me know, guys, if I know things are getting interesting, like some of your parents probably can't go to work and all that kind of stuff. So I've sent out some things about how to get food, like if your parents aren't working and aren't getting paid, then food might be something that you need. So I sent a message about how to get like a breakfast and lunch for yourself, but then there's also, they're going to be doing deliveries from like Student Impact, so that can feed your whole family. So just please reach out to me, or I'll send out, they provided a little bit more information about that today, so I'll send that out to you guys too as well if you need anything like that. Okay? Alrighty. We're going to, this is not going to feel a lot different than what we did the other day. So we're basically adding on area of a circle. And then on the back you'll see here, we're going to do like area of a shaded region. So if we want to find this shaded area, we'll just take the circle and subtract the triangle since the triangle is not shaded. So you guys already know how to do the triangle, you already know how to do the hexagon, so we're just kind of adding the circle onto that, and then you'll have to subtract the two shapes. So not too much different. And then we have a couple other problems that we're going to try today as well. So let's start with area of a circle. The formula is pi r squared, and you've probably done that before back in middle school. So remember that r is for radius, and then pi, that's a button on your calculator. Okay, it's 3.14159, so on and so on and so on. But you would just hit the pi button in your calculator if you wanted to put that into your calculation. Okay? All right. Another thing I should probably mention is on some problems they might give you diameter, d for diameter, and diameter is 2 times the radius. So if they give you a diameter of 10, your radius would be 5, okay? All right, so example 1. You are having a party and you want to make a cake. You have a Pillsbury cake mix that makes 1 10-inch cake, and you have a Betty Crocker cake mix that makes 2 5-inch cakes. You want to feed the most people. Which cake mix should you use? So should you make 1 10-inch cake or 2 5-inch cakes? Which one would make more cake? And we're going to assume that the cakes are the same thickness, so we don't have to worry about that. So a lot of times everyone thinks, oh wait, wouldn't that be exactly the same thing? So I'm going to show you 2 different ways to look at this. So I'm going to just show you how you could do this problem with a picture, and then I'll show you how you could calculate it as well. So 1 10-inch cake. When they say 10-inch cake, like if you go to a pizza place and they say, we have a 14-inch pizza, that's the diameter. So when they say 10-inch cake, they mean the diameter is 10 inches. So this is a 10-inch cake. That means the radius would be 5 inches here and 5 inches here. Okay, so there is our Pillsbury cake mix, 1 10-inch cake. Now, a 5-inch cake is going to have a 5-inch diameter, okay? So you can kind of imagine, here's what your 5-inch cake would look like. It would have a diameter of 5 inches, okay? And it would look like a circle. And then the other 5-inch cake, same thing. That would be right there. And then you can see with your own eyes, okay? My picture is not perfect. These are not perfect circles, but they are close enough for us to believe the picture. We can see that 2 5-inch cakes would fit inside of a 10-inch cake. So we already know that we want to make the Pillsbury 10-inch cake because it's more cake. Now, if you wanted to calculate this, here's how you would do that. So area of the 10-inch cake. You would go pi times the radius squared. And remember, if the diameter is 10 inches, the radius is 5. So this would be 5 inches. And you would get 25 pi inches squared. That would be your area. Okay? Now, the area of 2 5-inch cakes. Okay? We would take 2 times the area of 1 5-inch cake. But we have 2 of them, so we're going to multiply by 2. So a 5-inch cake would be pi times the radius squared. And remember, if our diameter is 5 inches, our radius is 2.5 inches. Okay? So this is the radius, this is the area of a 5-inch cake. We're multiplying it by 2 because we have 2 5-inch cakes. Okay? So 2.5 squared is 6.25. And if I multiply that by 2, I get 12.5. And then we have pi next to it. And then our units would be inches squared. Okay? And again, doing it with this method still shows us that the 10-inch cake is more cake. It's 25 pi. This one's only 12.5 pi. So the 10-inch cake is definitely more than the 2 5-inch cakes. So again, make the Pillsbury 10-inch cake. I am fine with you just doing this or just doing this. You do not have to do both. You can pick one method. You just need to be careful. Drawing a picture doesn't always work, okay? Here's what I mean by that. So there's a problem in the book where it talks about, and I'm just going to do this on a separate sheet of paper really quick. Give me 1 second. I've got some extra paper here. So there's one problem in the book where it talks about a 9-inch cake. So a 9-inch cake. So that means 4.5 inches here and 4.5 inches here versus 9 3-inch cakes. So we can think about, okay, I'd have a 3-inch cake here, a 3-inch cake here, and a 3-inch cake here. So that would be 3, 3, and 3. That would add up to 9. And then I could do the same thing vertically. 9 inches here, 3 inches here, 3 inches here, and 3 inches here, okay? But then what starts to happen is when I try to fill in more 3-inch cakes, because they said we were going to have 9 of them. I have 1, 2, 3, 4, 5. If I start to put in another one here, the circles start to overlap. Like there's an overlap right here. And then there's blank space right here. This is blank space. And I don't know if the blank space and the overlap spaces are equal or not. So at this point, it's too hard to tell if the 9-inch cake is more or less than 9 3-inch cakes. You can't tell because there's overlaps and there's blank spaces, and we don't know how that's all working out. So this would be a situation where a picture is not going to help you, and you would need to actually calculate the areas. Okay? But here, it's fine to draw a picture because nothing's overlapping. Okay? All right. We are going to skip this example, okay, and we're just going to flip over to the back. Okay, so find the area of the shaded region. Assume that the triangle is equilateral, okay? So, our shaded area is going to be the circle minus the triangle. Again, we have to subtract the triangle because it is not shaded. Okay, so let's plug in our formulas. For a circle, we always do pi r squared. And for the triangle, we're going to do what we did yesterday. Okay, so I'm going to bring it down here. Okay, we're going to find the area of this triangle, and we're going to multiply it by 6. 2, 4, 6. Okay, so we're going to do 6 times the area of the right triangle. Okay, So let's go over here and let's figure some stuff out. So let's figure out the area of the triangle. So first we're going to figure out this angle. It's going to be 360 divided by 6. Again, we're dividing by 6 because there are 6 of these right triangles inside the big triangle. And we get 60 degrees. In a 30, 60, 90 triangle, this is your 2n. So your n is half of that. So your n is 2 meters. And then this side would be 2 square root 3 meters. Okay? I think we have all of the information we need to go ahead and fill in all of our variables here. So the radius of my the radius of my circle from the center out to the edge, that radius is 4. So we're going to put in 4 meters and we're going to square it. Minus 6 times the area of the right triangle. And the area of this right triangle is 1/2 the base times the height. Okay? And now we're going to simplify. So 4 squared is 16. So 16, and then we put the pi next to it. Units would be meters squared. Okay, over here, 6 times 0.5 times 2 times 2. You can punch that into your calculator. You get 12. Okay, and then you put the square root 3 next to it. Meters times meters is meters squared. And this is our exact answer. That's exactly what this is equal to. Okay, and then I can also find my approximate answer. So the approximate answer, I'm just going to plug this into my calculator. And I'll show you how to do that without getting confused, okay? So we'll go, turn it on here. Okay, and we'll go 16 pi and hit enter. Okay, so that's what this is equal to. I'm going to keep that entire number, even the stuff that's running off the calculator, I'm keeping all of that in the calculator. And then I just hit minus, so I'm taking this answer, and I'm subtracting the rest of this. So in parentheses, 12 square root 3. Close up the 3. There's kind of a glare right there. I'm sorry. Let me move that. There we go. And then you got to close up the first parenthesis as well. Close that one up. Okay? And then hit enter. And you should get approximately 29.5 meters squared. Okay, so that was our first example. Let's just try another one. Okay, so on this one, our shaded area is going to be circle minus hexagon. Because again, the hexagon's not shaded, so we have to subtract that. Okay, for a circle, we do pi r squared. And for the hexagon, look over here, we're going to take the right triangle and multiply it by 12, because I can fit 12 right triangles inside my hexagon. 2 here, and that would happen on every side. So 2, 4, 6, 8, 10, 12. So 12 times the area of the right triangle. Okay, so let's not plug in everything we know yet. Let's come back over here and let's figure out this angle. It's going to be 360 divided by 12. Again, we're dividing by 12 because there's a circle here, and then there are 12 triangles. So we're taking that circle and dividing it among the 12 triangles. Okay? So we get 30 degrees. So this is a 30, 60, 90 triangle. Okay? We have to figure out the base of it so that we can find the area of the triangle. So again, some of you can do that part in your head, and some of you maybe not, so we'll just jot it down. 12 is our n square root 3. Solve for n. So divide by square root 3, divide by square root 3. You now have n by itself. So this is your n. We just need to simplify it. We're not supposed to have square roots in the denominator. So we multiply by square root 3 over square root 3. And that's just 1. That's why we can do it on the left side without having to do it on the right side. Our numerator becomes 12 square root 3. Denominator becomes 3. And then let's simplify that. 12 divided by 3 is 4. Okay, so our n is 4 square root 3. Since this is meters, this will be meters. Okay, and then this will be 8 square root 3 meters. This is your n, this is your 2n, this side is your n square root 3. So this is 4 square root 3 square root 3, which simplifies to 12. Okay, so let's plug everything in. So the radius of my circle, from the center of the circle out to the edge of the circle, that's 8 square root 3. Okay, and then we got to find the area of our right triangle. So we do 1/2 the base times the height. All right, now I'm going to show you how to put this in your calculator without messing it up. So you have to use parentheses because you're squaring the whole thing. You're not just squaring the square root 3, you're squaring 8 square root 3. So you got to go parentheses, 8 square root 3, close up the 3, close up the whole thing, and then square it. Here's your squared button right there. Okay, and hit enter. So you get 192. So this is 192 pi meters squared minus, okay, in my calculator, I'm going to do 12 times 0.5 times 4 times 12. And I get 288. And then there's a square root 3 with it. Meters times meters is meters squared. This is my exact answer because I have not rounded anything yet. So this is exact. And then I could round that if I wanted, okay? So here's what I would do again. I would hit 192 pi, enter. So that's this part. And then keep that entire number in your calculator, and from there hit minus. So we're taking that answer and we're subtracting all of this. So we've got to put it in parentheses so that we subtract everything. So we're subtracting 288 square root 3. Close up the 3, close up the whole thing, hit enter. So we get approximately 104.4 meters squared. Okay, and the last one, okay, our shaded area is going to be the circle minus the triangle. This triangle is different though. This is not a regular triangle. It's not equilateral like this one up here, okay? This big triangle is equilateral. This one down here is not. I can see that because this is a 90-degree angle and this is a 30-degree angle. So it is not an equilateral triangle. It's actually a 30, 60, 90 triangle, okay? So just like we've done on the other problems, we're still going to do pi r squared minus, and then for this triangle, I cannot break it into right triangles like I did up here. So this triangle, I took the whole big triangle and I split it into 6 right triangles. Okay? I cannot do that down here. Okay? So all I'm going to do is find the area of this triangle. And I can find the area of that triangle by doing 1/2 base times height. Okay. It says that the circle has a radius of 6. So this radius is 6 and this radius is 6. So plug in 6. Okay? Now, in a 30, 60, 90 triangle, this side is your 2n. Okay? So this 12 is our 2n. That means n is 6, and this is 6 radical 3. So this is n, this is 2 times n, this is n square root 3. Now remember, I can pick any side of my triangle to be the base, but base and height have to make a right angle. So I'm going to choose this as my base, and then this is my height because they make a right angle. So So the base of my triangle is 6. Height of my triangle is 6 square root 3. Okay, and we end up with 36 pi. And there was no units here, so like you could just put units squared, or you can just leave it as 36 pi. And then over here, we're subtracting 18 square root 3. So that's your exact answer. And that is approximately, let's find out, 36 pi minus, in parentheses, 18 square root 3. And we get approximately 81.9. And again, it would just be units squared. .9 units squared. Okay, so that wraps up our notes for today. Check Canvas to see, find your assignment. Thanks, guys. Bye.